Right, so we had already talked a little bit about 75, and that the first thing you had to do is make the thing equal to 0. It's quadratic, I'm supposed to factor, and you might look at this going, oh, this is one of the easier ones because the leading coefficient is 1. And then you try to factor stuff, and then it just doesn't work out, right? Because, remember, with the easier one, I'm just looking for two things that multiply up to negative 35 and add up to negative 12. So my little factoring game would go, what times what equals negative 35, and what plus what, same two factors, supposed to add up to negative 12. So when you think about it, it's like, oh, I got it, right? I've got it. It's got to be a 7 and a 5. And then you think about the signs here. One of them has to be negative in order to get a negative 35. And so then you look over here and you go, oh, I got a negative 12. That means the bigger one has to be negative, right? But if you make this a negative 7 plus a positive 5, you get negative 2, not negative 12. The only way that would work is if they're both negative, and if they're both negative, then the product's going to be positive. And so nothing works out. You can't choose any different factors than that. So what does that mean? It means this is complete rubbish, first of all. And factoring doesn't work. Factoring doesn't work whenever your quadratic is prime. Remember what prime numbers are? Prime numbers are numbers that are only divisible by 1 in themselves. And the same thing happens with quadratic equations as well. So we can consider these kind of ones that are factorable as not prime, sort of like composite. It's like these two things being multiplied together. So what do you do in those cases? In those cases, your fallback plan is something that always works no matter what for all quadratic equations, and that's the quadratic formula. Quadratic formula, x, that's what we're looking for, is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And remember, that comes from ax squared plus bx plus c is equal to 0, where your a value is the number, the coefficient of x squared. Your b value is the coefficient of just the b. That's right there. That looks really bad. I'm not going to use that color. And then finally, your c value is the constant that's left over that goes right there. Now, I can just kind of underline it. Yeah, that's good. All right. Now, keep this in mind whenever you're using the quadratic formula. Do not take the x's into the formula. You only take the numbers with their signs. However, this b that's here, if it's a negative 2, it's going to be squared, which is going to make it positive. Sometimes that makes some sort of sign errors if you don't take that into account that's right here. Because remember, inside of the square root, this whole thing has to be positive. If it's not, it's an imaginary number, which means that this quadratic equation has no answers. It's supposed to have 2, but sometimes it has none if this thing on the inside here is a negative number. It's also possible to have only one answer, and that happens if this on the inside here is just equal to 0, because you'd be adding and subtracting 0. Which brings me to the fact that you are supposed to have two answers, and the two answers come from negative b plus the square root divided by 2a, and the other one is negative b minus the square root divided by 2a. We just make it in compact form here, so they don't have to write it as two separate ones because it looks really similar. The numbers are actually called conjugates, if that matters to you. But we just put them together in one compact form. So if you would like, I will do not yours, but just some random one. Why don't we try some random x squared plus x plus 1 equals 0. All right, now actually I want to make this a minus 1 because I think that's going to make if I had a plus, I know that the parabola is going to be up above. If this was a parabola up above the x-axis, it wouldn't be solvable. You wouldn't have any answers. I think this one you'll have some answers on. So if I'm going through the process of trying to factor this, which is what I would suggest trying to do first, and the reason why is because when you take the SAT, the PSAT, actually, as a 10th grader, there's going to be a portion on it that you cannot use a calculator on. And so, with those quadratic equations that pop up on it, you got to be able to do it without a calculator. Usually, it's easier to do factoring without a calculator than it is the quadratic formula. People usually instinctively try to throw this whole thing right into their calculator. Okay, anyway, let's get back to this one. Let's play our factoring game and go, what times what is equal to -1? That's this -1, the C value there. And whenever I add them together, I get, well, the leading coefficient of the x term, which is just 1, so +1. So what times what is equal to -1 and then adds up to +1? That's not going to work because the only factors of 1 are like 1 times 1. If I did 1 times 1, well, that's not going to work because it has to be a negative times a positive. But if I did that, then they would add up to 0. So again, trash, it doesn't work out. So my fallback plan, quadratic formula. I just have to figure out what my A, my B, and my C are, which is pretty easy to do. A is equal to the 1 that's right in front of the x squared, the quadratic term. So 1. My B is also equal to 1. It's the implied 1 that's here. And my C value is equal to -1. It's this green thing that's at the end. And then throw them all into the quadratic formula. I'll rewrite it down just in case you missed it before. X is equal to -b plus or minus the square root b squared minus 4ac all over 2a. Plug in my a is 1, my b is 1, and my c is -1. And I have x is equal to -1. My b value is already 1. This is asking me to negate it or take the opposite of it. Plus or minus the square root of b squared, so 1 squared is 1 minus 4 times a, 1 times c, -1. All of this over 2 times my a value of 1. And then I just got to clean the thing up. I would have a -1 plus or minus the square root of, and on the inside here, I'm going to multiply -4 times 1 times -1. All of this is going to make this into a +4, which is very nice because now it's going to be a positive number. Whoops. A positive number inside of that square root. All over 2 times 1 is 2. And finally, a -1 plus or minus the square root of 5 all over 2. So again, quadratic is supposed to have two answers. There's two answers hidden in here. One of them is x is equal to -1 plus the square root of 5 over 2. And the other one is -1 minus the square root of 5 over 2. Our answers here are irrational. And that's what's going to happen when you can't factor it. When you can't factor it, like using the AC method or the guess and check method, then your quadratic is prime, and your actual answers are going to be irrational numbers like this that look identical to each other. The only difference is the positive and the negative sign, and those things are called conjugates. And that's the kind of thing that happens over here on number 75. And if you look back up at the instructions, it says all but one of the following problems can be solved by factoring. I think we found that one.